All right, so we have problem 7 here. A tank in the shape of a wedge is 10 feet wide. The top is flat with a length of 12 feet, and the bottom is 6 feet deep on one end. Find the work to pump out all of the water from the top of the tank. All right, so we're thinking, first we have to draw the shape. All right, the shape is a wedge. Now, what is a wedge? A wedge is think of it as like a block of cheese or a door stopper. Basically a 3D right triangle. So what we're going to draw is a 3D right triangle. So we are going to draw very carefully. That's basically a wedge. All right, so this is my wedge. And what we have is now we are looking for information on the lengths. So we have a wedge is 10 feet wide. So 10 feet basically here. This whole bottom area is 10 feet wide. We have a flat top of 12 feet. This is the top right here, this slope area of 12 feet. And we have 6 feet deep on one end. And since this is a right triangle here, 6 feet deep is 6 feet right here, 6 feet. All right, so now that we have that, we are going to set our bounds. So our bounds are going to be, this right here is going to be 0, 12, and then, I'm sorry, this is 12, 0, and 12, 6. All right, 12, 0, 12, 6. That means our bounds are going to be in the y direction. They are going to be from 0 to 6. That is our bounds. Now, what we need to find is the weight density. We need to find the area slice. And we need to find the distance. All right. To find weight density, it is given to us. Weight density is going to be 62.5. Now for the area slice. We are trying to find out what is all of these area slices. Well, you can set a relationship here. It's going to basically decrease in a depth from 6 feet to 0 feet over a length of 12 feet. Decreasing, we can create a linear relationship. So this is going to be 12 feet, basically our x, over our y, which is going to be 6 feet, giving us 2y. 2y is this linear relationship. Now, we need to have our bounds for our constant here, which will never change. 10 feet wide never changes. So we have 10 times 10. 2y times 10, giving us a total of 20y. That is an area slice. 20y is our area slice. Distance. Well, what is the tippity top? 6 feet. What can it only go down by? To 0, but it can go also here to 5, 4, 3. So this is going to be 6, which is our tippity top, minus y, because we are using y. So now we have our weight density, our area slice, and our distance. Now we can set this integral. 62, put it over here, 62.5 times 20, because we can get rid of these 62.5 and this 20, so we're just going to times these together to get 1,250y, and then we still have this 6.5y, but for this we can remove 1,250 150. But we still have to keep the y in here and the 6 minus y. So now we have 1250 over the bounds of 0 to 6, y, 6y, and we have our changes of y, which is going to be dy. All right, this is our integral. Now, to solve for this integral, we have to distribute the y. So, distribute the y. This is 1250 is going to stay 0 to 6. Distribute the y. This is now going to become 6y minus y squared, and we still have dy. Erase this right here. All right, we have this now. Now that we have this, what can we do? We can take the antiderivative. All right, so this is going to be 1250 is going to stay here. Going to have like this. This becomes plus 1, 2 divided by that 2. This is going to become 3y squared minus this becomes 3, and this becomes 3, 1/3. So 1/3 y cubed over the bounds of 0 to 6. All right, now we can solve this integral by plugging in our bounds. We are going to start with this 6. So we are going to have 3 times 6 squared minus 1/3 y. 1/3 minus, 6 cubed. All right, this is our plug-in. This is 36 times 3, which is going to give us 108. Put 108 here down here. Now we have 1/3 times that 6 to the 3 cubed is going to be 216. 216 divided by 3 is going to give us 108 minus 72, which gives us a total of 36. All right, we have 36 now. Now we have to plug in our 0. And to show our work, if you plug in 0, you get 0. So that is 0. So 36 minus 0 is going to be 36. But what did we forget? We forgot to times this by that 1250. All right, 36 times 1250 is going to give us a grand total of 45,000. All right, now that we have 45,000, can we circle or box our answer? The answer is no. We can't box our answer yet. And the reason for that is because we didn't put our units. Now people think, okay, so work. We're going to think about work. What is going to be work? It's going to be joules. No, it is not joules. Since we have a weight density of pound per feet cubed, this means we are going to have feet per pound. And that is our final answer. All right, and that's how you do number 7.